Okay, picture this. You've got exactly 20 minutes before your Cambridge IGCSE mock computer science exam starts. Every single mark is on the line, and your grade boundary, it's hanging by a thread. You sit down, open that paper, and boom, there's a high mark question staring right back at you on clock speed and performance. Are you ready to guarantee top marks on it? Let's dive into this explainer and make absolutely sure that you are.
Listen to this answer. A higher clock speed means the computer runs faster. Sound familiar? It's a completely realistic and, honestly, incredibly common student answer. You might have even written something exactly like this during your own revision. I mean, it feels right, doesn't it? It sounds perfectly logical. But in the context of the Cambridge 0478 syllabus, this is a massively dangerous trap.
Here's the harsh reality. An examiner is going to award exactly 0 marks for that answer. No way around it. Why? Because it's just a generic label. It completely lacks any real process explanation. In IGCSE computer science, you do not reach those top-tier marks by just writing down short labels. You've literally got to prove you understand the digital mechanics happening beneath the hood.
So why does ordinary passive revision completely fail here? Well, students often just memorize terminology in total isolation. They end up confusing these closely related concepts. Think about how easy it is to mix up memory with storage, or get tangled between logic processing and arithmetic processing. Your revision notes have got to train you on comparison, because if you can't distinguish between two nearby concepts, the exam paper is going to expose that gap immediately.
And this leads us to the crucial point, avoiding what I call the context trap. Knowing the theory, that's only half the battle. The major slip-up happens when learners know their definitions perfectly, but they completely fail to anchor those explanations to the specific scenario provided in the question. If the exam asks you about a school network and you just give a textbook definition of clock speed without ever mentioning the school, you are bleeding marks.
Let's fix that right now. Here is your first quick win. Before you write a single word of your answer, use this disciplined 3-step methodology. Step 1, identify the exact task requirement. Step 2, classify the relevant data or hardware. And Step 3, explain the process sequence. This totally stops you from just brain dumping everything you know without direction, and it keeps you laser focused on what the mark scheme actually wants.
Now, we're approaching a really critical juncture. In just a moment, I'm going to show you the exact examiner clue that transforms a 1-mark guess into a guaranteed full-mark top-band response. It is the absolute secret to unlocking the toughest questions on the paper. But first, you need the framework that makes that exact clue completely obvious to spot. So let's look at how this builds.
This is your core memory structure, just 4 simple prompts. What is it? How does it work? Where is it used? And why is it better or worse than the alternative? If you can answer these 4 prompts out loud right now, then the topic is ready for the exam. But if you can't, you aren't ready yet, and you're going to need to rebuild your knowledge starting from a worked example. Let's apply our what and how prompts specifically to clock speed. We don't just say, it's the speed of the computer. That won't cut it. We define clock speed by the specific digital process taking place. It determines the number of fetch, decode, execute cycles the CPU can perform per second. It solves the actual digital problem of how quickly instructions are processed sequentially. See the difference there? That is top-band precision. Next up, we apply the where and why prompts, because the exact same theoretical patterns appear across totally different real-world technological scenarios. The exam might drop you into a context involving smartphones, school systems, robotics, or maybe even secure communications. The reason for choosing a higher clock speed and the actual real-world consequences of that choice have to be tied directly to these distinct environments. Okay, let's really raise the stakes here. Here is a much harder, specific Cambridge-style scenario. An embedded system in a factory robot gets a processor upgrade. Explain the impact. The pressure is on. How do you apply our framework to this without falling into that context trap we talked about earlier? Well, let's take a look at how a typical student might tackle this one. Take a look at this student answer. The robot has a better clock speed, so it moves faster and is better. I want you to literally pause for a second right now. Play the role of the strict examiner. Can you spot exactly why this new answer is fundamentally flawed? What crucial elements are just completely missing from this explanation? All right, let's do an examiner-style correction together. There are 3 classic wrong turns happening here. First, vague wording. What does better even mean technically? Nothing. Second, missing process steps. There's absolutely no mention of fetch execute cycles. And third,
naming an outcome without explaining how it actually works. Just saying it moves faster entirely ignores the digital processing happening inside that embedded system. This brilliantly illustrates the difference between average and excellent. A generic zero-mark response just guesses, but a context-anchored top-band process sequence, it sounds like this. A higher clock speed increases the number of instructions the robot's embedded processor executes per second, allowing it to process sensor data faster and react to factory obstacles more quickly. Boom. Precise terminology directly connected back to that factory context. Remember that clue I promised you earlier? Here is the ultimate examiner clue: specificity and scenario anchoring. The clue is checking whether the question wants causes, effects, or design decisions specifically anchored to the given context. If you read the scenario and your answer could apply to literally any computer in the world, you've missed the clue. Your answer must live inside the factory, the school, or the smartphone. To build true exam adaptability, you need this 3-pass revision cycle. Pass 1, secure your key definitions and contrasts. Pass 2, rehearse those worked explanations and diagrams. And Pass 3, adapt to changing scenarios. Try changing the robot to a banking system. Mix up similar terms. Force yourself to justify the choices. This layered style of revision is exactly how you beat the 0478 syllabus. Let's do a rapid final recap of our high-mark strategy. Number 1, don't confuse similar terms like memory and storage. Number 2, always use the 4-prompt framework to test yourself out loud. Number 3, always, and I literally mean always, anchor your explanation to the context provided. And finally, avoid generic labels at all costs. Generic answers get generic grades. So here's the thing. You now know how to absolutely nail a process question. But this leaves a massive unresolved problem. You can explain a process perfectly, sure, but what happens when the exam throws a curveball and asks you to evaluate alternatives? How do you structure an evaluation for maximum marks without losing your train of thought entirely? That is exactly why mastering the top-band evaluation framework is your absolutely mandatory next step to survive these mock exams. Explaining a concept is really only half the syllabus. Evaluating different technologies is where the distinction grades are actually won or lost. Our mock survival plan continues next, and trust me, you need this framework. You literally cannot afford to skip this next part, because if you can explain a processor but can't evaluate whether it actually belongs in that factory robot, have you really understood the system at all? Click the explainer on the screen right now to master the 0478 evaluation framework. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. I will see you over in the next explainer to finish your exam prep.